Tuesday, January 18th. Our second week of our population and resources. What caused the Moon Sally population in the Glacier Sea to increase? I want to quickly lead us off with the video today as we talked last week about seeing how do populations affect one another. We also talked about where the moon jellies fit in the Glacier Sea food web and ecosystem, how they interact with different organisms, and then we capped off last week with a reading. This week we're going to move into how do we know the population of the moon jellies? Like, how do scientists know how do they do that? How do they estimate it? And then start talking about energy this week. If organisms eat other organisms to obtain energy, we're going to look at how they do 2 simulations and a couple of readings this week and how it works like that. Before we start, I have a quick video on how our ecologists in the Everglades, down in Louisiana, my mistake, how they study moon jelly populations. So please watch this quick video then I'll get you in the instructions how to do the following simulation.
My name is Dr. Kelly Robinson, and I am a marine ecologist who specializes in jellies. Jellies are one of the oldest animals on the planet. In fact, they've been around for over 500 million years. The term jellies actually encompasses a wide number of animals that are representatives from several major groups. There can be a lot of different shapes, sizes, and colors. I love studying jellies because they're beautiful and also mysterious. There's so much to learn about their ecology and what the role in the ecosystem is. So as an ecologist, I go out on the field, on the boat, and I sample organisms in the ecosystem. I also bring them back in the lab to do experiments. And then I take what I learned there and I put them into ecosystem models. An ecosystem is made up of both living and non-living parts. As a marine scientist, I look at how the physical, chemical, and even geological factors affect the living organisms within that ecosystem, as well as interactions among them. The jellies are a natural and important part of our marine ecosystems. Jellies are both prey, meaning they are food for other organisms, as well as predators, meaning that they eat other organisms. Jellies are a food item for sea turtles. Another role that jellies play is that jellies consume a wide variety of animals, but mostly they're eating zooplankton. Zooplankton are free-floating animals that tend to be microscopic. In ecosystems, populations interact with each other, and this can actually form a very intricate web of populations all connected to one another. What this means then is when we see changes in one population, this can have an effect or an impact on several other populations within the ecosystem. We have records of changes in jelly populations for many different areas and for many different times. So it's very important for us to focus on what's driving these changes in jelly populations for a specific ecosystem. When jellies exhibit a sudden and rapid increase in their population numbers, they can become clumped together or very densely packed where individuals are very close to one another. In order to understand why we're seeing sometimes sudden increases in the population size of jellies, we need to have a better understanding of their role in the ecosystem as well as the impact of other populations on them. So if you're interested in jelly ecology, I would encourage you to think about becoming a marine scientist who specializes in jellies. We always need more scientists because if we have more scientists, then we can collect more data, and by doing that, we can get a much better understanding of the role that they play in our ocean ecosystems.
All right, so studying moon jelly populations, what we're going to do is we're going to open up the estimating populations simulation, and what it's going to look like is it's going to look like this worksheet when you open it up. Please open up the worksheet. Please store in a PDF. If you need to pause while you watch this part of the video, while you're opening the video, open up the worksheet. Okay, I'm assuming you have the worksheet pulled up. I will also put the link below here to access the simulation, but on our simulation here's our simulation, tagged fish, fish to catch. Interesting how this is going to work out. We have then, in our worksheet, a jar contains 100 marbles. Here's our pre-lab prior knowledge into how we estimate fish populations. A jar contains 100 marbles, some are black. You pull off 4 marbles, 1 is black. out of how many 100 marbles would you guess that are black? So if you have 4 marbles, you pull 1 is black. Well, I'm thinking of proportions here. What would it be out of 100? If I know, oh boy. If it's out of 100, if you can bear with me, if we know we pull 1 black marble out of 4. If I did this, I would assume then that probably 25, because 25 over 100 would be 1/4 equal there, so it'll be 25. And how would I know? How would I explain this? I would say the reason I think it would be 25 is because 1 in 4, because it's only a quarter, because there are only a quarter amount of black marbles to, yeah, only a quarter of them are black marbles. So then a different jar has 100 black marbles. The total number of marbles is unknown. If you pull 4 marbles out and 1 is black, what will your guess total numbers be? If the total number of the jar has 100 black marbles and you pull out 4 marbles, only 1 is black, I would probably say that the other 300, what is your total number? What is your guess is the total number of marbles? Well, if one black marble is pulled out of 100, but there's 3 other marbles, I would assume there's 3 times as much as the other one. So I'd probably say that there are 400. Let me write this out. 400. I don't know why it looks like this. I should probably use a better marker. Explain how you know. Why do I know that? How do I know this? Well, if 1 marble is black and the other 3 are not, if there are 100 black marbles, then there would be 300 marbles of another color, because that's the ratio, because there's a ratio. So in our Gizmo warm-up, we're going to estimate the total number of fish in a pond, kind of like we were doing with these proportions before. Suppose a scientist tags 100 fish and releases them. Set this tag fish to 100 to show this later. Later, the fisherman catches 50 fish from the pond. Set the fish catch to 50. The fish is able to catch all the fisherman's catch is a sample of all the fish in the pond. It's just an estimate. Click and catch. Look at the result. How many tag fish did the fisherman catch? Okay, so if we're in the simulation, we want a tagged fish to be 100, and then here's the fish to catch. We want to get that to 50. And then we catch and check. How many tagged fish did the fisherman catch? Well, the tagged number of fish was 20. So I would just write that in here, if it'll let me. Sorry, I could have wrote that better. If you had 1 fish out of this pond, what is the probability that your fish is tagged? So if we have the number of fish, what do we have? If you catch 1 fish out of this pond, what is the probability that your fish is tagged? I would say, going back here, the number of fish caught is 50. We had 20. So 20 fish out of 50 had been checked, which is 40%. So I would say 20 out of 50 fish. So to a decimal, that would be 0.4. Suppose you set the catch fish to $100 a pound. How many fish would you expect to be tagged? If we caught 50, if we caught 20 fish out of 100, out of 50, I would just double it. I would say 40. Explain how we know. I would say it would be 40 because we caught double the fish. Double the fish, so double the tagged fish should be caught. Tagged. All right, set the fish. Now you're gonna do. I want you guys to work it out now. Set the fish catch to 100. Check. Does the number tag show? Does it go with our estimate? Let's redo it. And let's set it up. Do we get 40 now? That's what we were expecting for. We got 36, so it's 36%. I would say no. No, we only got 36, which is close, I would think. It's only off by 4 fish. It's an estimate. Doesn't mean it's going to be perfect. That's what sometimes students get frustrated with. It's just an estimate. Doesn't mean it's going to be perfect. If you don't know how many fish are in the pond, you can use the results from the right to catch proportion. Fill in the blanks below, write the words in for this proportion. So, now fill in the space to the right, use the catch release. Select the calculate tab to your work. Choose your estimate for the actual fish population. So I will, So if you don't know the number of fish in the pond, you can use the results to write the catch proportion, estimate the fish, fill in the blanks to the words from this proportion. All right, so what that base is saying is go to our calculate. We had 36 over 100. 36 tagged, I would say 36 tagged fish were caught out of 100. Out of 100 total. So I just write, this is just total. I'll just start using text. So then, what did they do here? Well, they caught 100. Out of 100, if there's 100 tagged fish, how many would we expect? Yeah, it'd be about, we would expect to have, if we caught 100, if we had 100 tagged fish, how many total fish would there be? Total tagged. We don't know what the variable is here. So calculate the space, use the catch right proportion. So all we do is cross multiply 36 times, cross multiply 36 times x is 36x. Sorry, I'm not the best at drawing on this. Equals 100 times 100, which would be, what is that, 100? $10,000. And we divide both sides by, sorry, let me get to the worksheet, sorry. Lost my spot. Gotta get x by itself, divide by 36. So 10,000, if I type it in my calculator, 10,000 divided by 36 equals 277, just like the worksheet. So we would expect, what does this mean? If you have 100 tagged fish, we would expect there to be 277 total fish tagged. If you pulled up to 100 tagged fish, you'd expect to pull up 277 fish. So how close were we to our estimate? Well, let's run it. Tagged fish, fish to catch. 325. So yeah, how close were we in real life? So we explained before, fled it to 36. This is the total number. So how close were you at to the fish? We'd say pretty close. If I can get the text box to work. These are just estimates. We're trying to set up proportions. So from here, then, you're going to reset the next one. What I want you guys to do is try the second page yourself. If you have struggle with it, it's okay. Email me. We can Zoom for help. Turn on the pond tab. Turn off the show total catch fish. Select a new. Click new pond. Set the tag fish in the pond to the same number of your choice under 75. So I would say we're going to go pond. We're going to click new pond. And for this last problem, select on the pond tab, show total fish in the pond. Click the pond, set the tag fish in the pond. Fish to catch to your choice under 75. How many fish were tagged and released? So fish to catch, I'd probably say, let's set this under 75. Let's just go maybe 40. And your fish to catch like 50. Set up your proportions. So we had number 7. We caught how many fish were tagged and released. Well, the number of fish that we tagged were 40. How many tagged fish were 40? So I would say, boom, 40. Now click the check, fill in the blank space, the number of tagged fish in your sample. Blank out of blank fish were tagged. We would say 7 of the 50 fish were tagged. So, this is right your proportion. Okay, how many total fish are there in the sea? If we pulled up 7 tagged fish. Wish I could write this easier. That'd be tagged. And then we caught over 50. We knew we had 40 total tagged. What would X be now? We don't know how many total fish are in the sea. We want to figure out how many total for. If we tagged 7 and we pulled up 50, if we tagged 40 total, how many would we expect to see? Can you use this cross multiply? Can you do the rest of your math then to figure out how far? We'll turn on the show. You can calculate your answer here. What would X be? Then you can go back to the simulation and then actually show the total fish in the pond, and it'll give you your answer. So, and you can also check your work here, your calculations. So, try that. I know this is a lot. Good luck. Please email me if you have any questions.